Building a house involves a predictable struggle. You break ground, and for 6 to 8 months, the site is vulnerable to rain, missing supplies, and the logistical friction of managing human labor in the mud. This delay is a result of a strictly sequential process. In traditional construction, you cannot begin the walls until the concrete foundation has been poured, leveled, and allowed to cure. But there is a way to break that sequence. This is the moment a pristine, finished wall panel is lowered onto a new foundation. This is prefabricated construction technology, or PCT. It is a system that moves the most time-consuming parts of a build away from the site and into a factory. To build faster, the industry is moving away from site-based craftsmanship and toward a model of industrial manufacturing. When people hear the term prefab, they often think of shipping containers that have been cut open and stacked to create a living space. While containers are a form of prefabrication, they come with built-in compromises: a narrow 8-foot width and a steel shell that requires aggressive insulation to remain habitable. The real shift in home building relies on large-scale precast concrete panels. These are custom molded to fit the specific footprint and architectural style of a residential home. This isn't about living in a cargo box. It is about using industrial precision to create permanent, spacious structures that look and feel like high-end traditional architecture. Inside a precast facility, the environment is controlled. Concrete is poured over a steel grid engineered to exact specifications. This 3D cross-section reveals what is inside. The steel reinforcement cage is sandwiched between layers of concrete, with high-density insulation integrated into the core. Because it is factory-built, electrical conduits and plumbing are secured to the cage before the concrete is poured. Compare this to a traditional site, where workers often have to use hammers and power saws to cut channels into finished masonry just to make room for wiring. Moving these installations into a fixed mold provides a level of dimensional accuracy that is nearly impossible to replicate by hand on a windy construction site. To see how this saves time, look at this traditional timeline. Each phase, foundation, walls, roof, must wait for the prior to finish. Precast hacks this by running phases simultaneously. While the crew digs the foundation, the factory casts walls and roof panels. The concrete doesn't necessarily cure faster, but by allowing these two massive phases to happen simultaneously, the total project length is cut nearly in half. The most difficult phase is the transit. Moving several tons of finished concrete across standard roads requires precise route planning and specialized packing to prevent stress fractures. When the trucks arrive, the site becomes a zone of tight coordination. Mobile cranes hoist the panels into the air, relying on ground crews using guide ropes and laser levels to achieve alignment measured in millimeters. The structural integrity depends entirely on the connections. These panels are welded, bolted, and sealed together to ensure the joints are as strong and weather-resistant as the concrete itself. The speed of the on-site assembly is real, but it is a result of intense logistical planning weeks before the first crane arrives. Despite the efficiency, precast is not a loophole for exceptionally cheap housing. The materials and the engineering requirements remain high. In this comparison, shipping containers often cost more, up to $3,100 per square foot, due to the complexity of the retrofit. Optimized precast panels sit closer to $1,300, which is comparable to high-quality traditional builds. The budget simply shifts. You spend less on site labor and wasted materials, but those savings are often redirected into heavy trucking and crane rentals. There is also the issue of permanence. Once a concrete panel is cast with its internal wiring and steel, you cannot easily knock down a wall to change the floor plan later. Building with precast means trading future architectural flexibility for immediate structural durability and a massive reduction in total construction time. These houses are only as good as their design. Without proper structural engineering, even the best factory-made panels will fail at the joints if they aren't calculated for local seismic and wind loads. An engineering checklist is vital, requiring soil investigations, structural calculations, and a comprehensive erection plan before pouring concrete. Professional oversight ensures factory production and site assembly work as a unified system, focusing on structural safety. When the engineering is sound, the result is a massive compression of time. A vacant plot can be fully enclosed in a finished, structurally secure home in a matter of days rather than months. By turning the traditional construction site into an assembly point for manufactured parts, we trade physical chaos for intellectual planning. It is proof that to build faster, we must first learn to plan better.